diamonds in the rough. So today will be the second video of the next series, and as you have seen the first video where we have learned machine learning modeling through an example which was pretty cool, that was self-driving car, and because of that we learned about what is weight, what is training, what is all, right? And today I'm going to tell you how we can execute that in a Python or something, and how we can utilize GPU, or how we can use matrices to do those kind of operation in a very faster way, and why the GPUs are required for that cases, right? So that we can easily do. So let's get started. So if you remember our model weights, right? Some places we also call it theta, and in the previous example we use as weight, so we call it as a weight. So these were the golden numbers. The pattern around this number basically has some information where you actually pass on a new image, and that image will multiply and then add it together and it will come up with the prediction, right? So this weight has information inside it, the pattern has some kind of information, and we were changing the weights with our different training example so that we can reduce the loss, right? And that was we were doing. So problem is that when we do it in a programming language or maybe in Python, how we do is basically we loop through each operation, right? If I have to do this kind of multiplication, so I will run a loop and I will take out the first element of the weight, and then take out the first element of the example. I'll multiply and then again change the, iterate in the loop, and then somewhere I will do the addition part, store the addition somewhere, and so there are so many micro operations that you'll do. So you do it for one, save somewhere, store the value, then add together in the summation part, then again multiply, then sum, and then add together in the total sum. And that you do if you see, I think this is 16 weights over here, 16 pixels as well. So 16 times, so model predicted 68 over here, but if you see the number of times it did the multiplication was 16 times, because there were 16 numbers, right? So that's 16 times has been multiplied, and then plus is also 15 times. And if you see one, just to get one prediction, we are getting around around 30 operations we are doing just to get one solution, right? And the right way to do is that if you convert into a kind of a matrix, so this weight could become a matrix of 1,16 length, like basically one row with 16 columns, and this could also become 1,16, one row with 16 columns. And if I have to multiply it using GPU or something, what we can do is we can transpose. Instead of doing anything, we'll do a first operation called transfer, which you have already learned in matrix, right? Where basically if you transpose is basically the row becomes column and column. So the numbers has not changed, it's just we have aligned it in a different way. So 16 becomes your rows and there is one column, right? This way. And why we did it? When we actually do matrix multiplication, what it does multiply and then add together. So I don't have to separately do the multiplication and the addition part. So over here it will directly just multiply. Now I'll get the answer over whatever is this, right? We already have learned about matrix multiplication. So the answer we got over here 68, right? Same answer but in a different way. And the advantage is that in CPU, how we do it, basically you have adder, you have subtractor, you have multipliers, and then you have iterators, and these are micro operations which are called and everything. But in GPU, and to perform those operations, we have something called ALU, arithmetical logical unit, and then there are control system, there are cache, there is RAM, and these all things, right? So whenever we do multiplication or something, this has to reach to ALU. So if you have, let's say, 16 operations to do, right? So it will, now let's say CPU has 4 ALU circuits, right? So it could divide into 4 small pieces, right? 4 addition to this 4 ALU, and then next these 4s to this one, and then next these 4 this one, and then these like, so 4 ALUs will solve like 4 multiplication addition, then it will combine it using these cache and DRAM and everything, right? So CPU will break it into like 4 chunks and then do it or something like this, right? But with GPUs, actually you can just do the addition and multiplication exactly at once, because we have so many arithmetic ALU, right? This is a part of I don't know if you have understanding about this. This is a microprocessor, And microprocessor, inside there are memories, there are chips or circuit which actually do mathematical calculation and these all things. And GPUs, what it has more of those, right? And so that we can just multiply and add together separately. Like I don't have to depend on this one. So what happens is when you do addition, subtraction, multiplication, any kind of arithmetic operation, it will do over then wait for the result, and then again once it is not busy, it is idle, then again the next iteration will come and one by one it executes. But with having GPU, I can actually do it all together, right? You can see all together I can do it. So let's say in this method, when we actually did alone, we required 30 operation, as I've shown you, 15 multiplication, 16 multiplication, and around 15 addition, right? And imagine, like, if you have 6 example, if you remember from the previous example of self-driving car, if you have these kind of examples, 6 of them, so you will multiply 6 into 30, it become 130, something like this, right? So that will become 6 multiplied by how much? 30. I think that will be 180, right? So 180 operation you have to do to get the prediction for 6 example. But with matrix multiplication, what we can do is they can be done easily, like they can be done easily with without actually doing. So if you remember this, let me take that slide over there. So if I have to do for this 6 example, which I've seen previously, what I will do, I'll take the weight, multiply each term, then add together, I'll get a value, right? That will happen for 6 of them. So for this one, it took 30 steps. For this 30, again this 30 and 30. If you all together, the steps it will take to do matrix multiplication become 180. But what happens if you convert your this thing as a matrix? All 6 example is a matrix, basically 6 rows with 16 columns, right? And now I can multiply. First of all, it is not possible to multiply because it is not matching the criteria to do multiplication. So what we'll do, we'll transpose it, right, which you have seen previously as well. So transposing this, basically this will become 6 becomes 16, right? So it will become 16 rows and 6 columns. So that will be, yeah. Like I have transposed this for second step. And now if I do multiply, I need only one operations to get the output for these 6. So I'll get 6 prediction exactly in the blink of the eye. Right? So that is the power of GPU, right? And if I am able to convert my code into iterative way to more like a modular matrix way, right? Then actually I can transpose and make it multipliable, and then it will not take 30 operation per example, right? Instead it will just do it in a blink and you'll get the output for 6. Not for 6. If you could have more even examples, right? Or according to the size of GPU, you can pretty much multiply a very big matrix, right? So I can, let's say I have a matrix example of 500 example of this 16 pixels. So I can exactly get prediction of 5. So that is pretty amazing, right? So yeah, in the AI as well, we try to code our example such a way that we use most of the metrics and matrix multiplication so that we can get things faster. As you have seen our self-driving example in my first video of this series, I'll try to code that in Python and that we can see. So first we'll import this library NumPy, which is very helpful to do multiplications and all, right, and use matrices as well. So over here I'll create a kind of matrix only with rows and something like this. So we call it X variable, which is basically this one is the first example. Then we have second example over here, third, fourth, fifth, and sixth. All the 6 example I've taken over here, right? And how we got this example, if you remember, we took the image, we converted into black and white, and then black and white has this digit 0 and whatever the numbers were, and then we flattened it, right? Image was of 4x4 size, but this we flattened it. So this is the X image pixels, right? And 6 of them are there, and we have the Y value. So first image, if this was maybe left turning road or something, so it will have steering rotation -5. Other will be 10, 0, 9, 6, something like this, right? So these are the labels. If you print it, you can see the X shape of those. This is basically 6,16, right? This is one of the example. So to find that golden weights, right, which we were doing through trial and error, we don't have to do it, because using some maths, maybe the derivative which we have learned, using that this maximum minimum problem, we are able to calculate a formula, which I'm not telling how we calculated this, but I tell you this is the formula. If you just take the x transpose, multiply with again with itself, then take an inverse, then multiply with x transpose, then multiply with y. If you solve this, you will find those golden weights. You don't have to iterate and change the weights, see how loss is going down. You don't have to do any of those things. You can just directly got these weights, and this is called normal equation. This is linear regression with normal equation method, right? So this way we can exactly find the theta. Now how we can solve it? We'll use normal programming construct. So I will solve this part first, x comma this x transpose y. You can use np dot method over here, and x dot t basically does the transpose, and you have the y over here, and if you print you will get this value. So basically this part I have solved. I've taken this x16 6 example with 16 pixel values, multiplied with y, and did the transport and whatever the thing, I get this result, right? Now the second part of this equation, basically x transpose multiply with itself and then do the inverse. So over here first I'll do x transpose multiply by x, which I did. Dot operation, basically matrix multiplication with each other. When you do that, you get this value. Now we have both of the thing, right? We already calculated, and we can pass both of thing and multiply itself. So again the dot operation, np dot linear algebra, this is lin alg dot p inverse. So basically it does the inverse. So this xtx, well, this part actually, right? I did the inverse over here, and then you multiplied with x transpose y, right? And when you solve it, you get these theta values. So these are my weights, right? Which you have seen in the previous example, right? If you remember, this was the weights, right? This is the weights. We got it directly. And once we have these weights, if you remember, we tried with a new image, right? In that example, a green kind of image. So this is the new test image, which we have already pre-processed, and it is in a flattened form. And if I just do the matrix multiply each element with each other and then add together, if I do that, I'll get the value basically 12. And if you remember, the original value for this was minus 10 or 9 something, minus 9 I guess, right? So it is pretty close, right? Just using 6 example, I was able to tell, hey, you have to take a left turn, minus 10, minus 12. It is not that exact, but yes, still your car will be on the road with this minus 12 turn. And so this was one way to do it, right? And pretty sure we will learn how this formula came, right? You will be amazing, hey, where this formula came, how can I know, how can I believe it? So yes, there is explanation for that. And this is because this course we have designed to go through like first abstract form, then the deeper thing, like top to bottom approach. So I just want you to know how we can do it. And I want you to try this code. Also, if you don't want to go through this calculation, we have a built-in library called sklearn linear model, where you can exactly import linear regression class, then get that instance of the class, and there is a function called fit. Basically, fit does is you will pass x and y values, right? There it will do this whole method, right? And there this kind of thing, it will internally do all those things. Just you have to pass x, y, and once you do it, it will find the weights. The fit function basically finds the weight. And once you do dot predict with the example which you want to do, you can get the value. So if you see, this one has done a better job because they are using more techniques which I haven't told you yet, but probably will surely learn in future lectures. And we get this better answer because this formula, this class actually did better job than the formula we came up with, right? But we'll see what was the pitfalls and everything, right? So you can get the value minus 9, which is exactly what we were looking for, right? So you can use this library as well. And if you want result of those in 2 times, let's say I wanted to give 2 images example, so you can send 2 images like this, test, comma, text. In this case, I've just passed on another image, but you can change this test with test 1, 2, 3, another. Basically, this test is basically this array of 16 digit, right, pixel values. So you can pass this value and you can get multiple outcomes like this, right? So that is it. I want you to try this code and tell me if you have understood or not. So this way we can actually solve, right? You already learned how we can change the weights. So next goal is to maybe come up with one more example like this and see one more regression problem, which will be which you can actually try. Like you can give your input as well. I want more realistic example than this, so that you can actually try with your own hands. And the next will be to explain you how this equation came, like how this formula came, how we derived it, how it actually works, and then tell you why this one is also doing the same thing but some extra thing just to make it better, and what was the missing things are, right? So we will probably do that. So see you in that video as well. I hope this video gives you a lot of value, and if you have any comments, suggestions, which you can write, I will really love to read them, and that it will motivate me to improve it, or maybe give me more motivation to make more videos. So that will be helpful. So yeah, I believe that you will win the next video. So see you in then. So keep subscribing.
Thank you for all your support.
You. Who are you?
My God! I'm gonna become stronger than anyone around.